Okay, so we left off here. Now I'm going to part 2. So we finished up our alpha levels. We decide these alphas based on the context of the situation. We have our one-tail and two-tail test, and also when we've chosen our alphas, we now know our one-tail or two-tail. We're able to then say our confidence interval we should use, the percentage we should use our confidence interval. So I want to finish up this chapter is type 1 and type 2 errors. Now specifically, type 1 is an RT. And RT, we stands for really true. Type 1 error is made if we reject the null hypothesis when in fact it was true. And that's a way of thinking about it. Specifically, though, we say we never actually proved the null hypothesis, but it's saying we rejected it when we shouldn't have. Type 2 is an AF. It's actually false. Now, it's made if we fail to reject, or sometimes people say accept, but they mean fail to reject, the null hypothesis when in fact the null is false. So these are the types of errors we can make. First of all, we make our decision based on the sample. We can reject the null or we can fail to reject the null. And if you look at the top here, it said the truth about the population. The truth is either that the null hypothesis is true or the null is false. If the null was true but we rejected it, that's a type 1 error. Our chance of making a type 1 error is the alpha. As soon as we decided on that alpha of 0.01 or 0.05 or 0.10, that is our probability of making a type 1 error. Our type 2 error is called beta. You won't have to calculate beta. We're going to do an example where we do calculate it, but this is also where their null hypothesis was false, but we failed to reject it. Now, these have other names you're probably more familiar with. By the way, we have a correct decision. Let's finish up our chart. A correct decision where we rejected the null and the null was false. This is called the power of the test. This is how you interpret the power of the test. It is the ability or the probability to reject the null hypothesis when the null hypothesis is false. Now, another correct decision is to fail to reject it when the null is actually true. We don't have a separate name for that other than it's a correct decision. These are also called, a type 1 error is a false positive because we wrongly said there was an effect. Type 2 is also called a false negative because we wrongly said there was no effect. So when you have your alpha, that is your chance of a false positive. When you choose it, you're making a decision of how willing you are to take a type 1 error. Beta, it's just the probability of failing to reject it. Now, there is a trade-off of these, and I may say it again in a moment, but they're just so important I'll bring it up right away. When we increase alpha, we are actually decreasing beta. If we're more likely to make a false positive, we're less likely to make a false negative. Now, at the same time, if I decrease my probability of making a false positive, if I decrease that, my alpha, I say, I want my alpha to be 0.01. I've actually increased the chance of a false negative. So there's a trade-off between those. So if I want to lower my false negatives, I can increase my chance of false positives. Now, power, again, it's a correct decision. We find it by 1 minus beta, and we normally want high power. This is the probability our test will correctly reject a false negative. We want high power tests. So what would Houdini do? You don't know who Houdini is? That's okay. He's Houdini's less famous cousin. So let's try this. This is Houdini. Houdini has a couple bags, and he's going to do a couple tricks for us. Now, the way this works, because like I said, he's Houdini's less famous cousin. He has bag 1 and bag 2. In bag 1, we have, it should be 17 red balls, 2 green balls, 1 blue ball. And in bag 2, we have 1 red ball, 4 green balls, 5 blue balls. So the question to Houdini is, which bag does he have? So he has a couple hypotheses. He's going to one of these bags is going to be randomly chosen. Without looking into the bag, he's going to reach in, remove 1 ball. After looking at the color of the ball, he'll make a conjecture about which bag he has. So he has a null hypothesis. He's going to have an alternative hypothesis. He's going to figure this out, and he's figuring out what his test is. So first one, let's just assume for the moment that bag 1 is preferable to bag 2, that we prefer the bag that has 17 red balls over the bag that has 1 red ball. So that means his null hypothesis is to have bag 1. His alternative hypothesis is he doesn't have bag 1. So he decides he's going to conclude which bag he has if the ball he pulls out is red, because he has a better chance of getting a red ball from that bag. So otherwise, he's going to say the bag is bag number 2. So statistically speaking, his null hypothesis is the bag is bag number 1. That would give him a mu equals 1. His alternative hypothesis is that he doesn't have bag 1. Not that he has bag 2, but that he doesn't have bag 1. Remember, our hypothesis and null hypothesis is always in terms of the null value of having bag 1 or not having bag 1. It would just mean mu is not equal to 1. So he's going to do a two-tailed test. Now, in this case, it turns out he has bag number 2. So there are 2 types of errors he can make. Yeah. So apologize for that, a little bit of phone ringing. So Houdini can make the mistake. He can reject the null hypothesis when the null is actually true. The other mistake he can make? Well, he could fail to reject when the null is false. So type 1, it means it was really true. That's a way of thinking about it, just a way of thinking about it. Type 2 is actually false. So let's see, a type 1, remember, a type 1 error can only occur if the null is actually true. And in this situation, that would mean Houdini concluded he had bag 2 when he actually had bag 1. It's the only way he can actually make a type 1 error. The probability of a type 1 error here, what's the number of balls in bag 1 that are not red divided by the number of balls that are in the bag. So this is a chance he'd say he has bag 2. He'd have to pull a not red ball out of bag 1. There's 3 of those out of 20 at a 0.15. Now, type 2 can only occur when the null is false. And in this case, that would mean Houdini would have to say, well, I have bag 1, but he actually has bag 2. And in this case, we remember he only had the 1 red ball in that bag out of 10 total. So his chance of making a type 2 error is just 0.1. So the power of the test, now these are just the chances. We have our chart, we could fill it in at this point. So the power of the test is a probability he will reject the null when it turns out he should reject the null. It's a probability of finding the alternative true when it really is true. So in this example, and this is a pretty simple one, the power of the test is a chance that he will pick bag 2, that if he got bag 2, he would correctly reject bag 1. They'd say he doesn't have bag 1. So power of this test is going to be 1 minus the chance with type 2, or just 1 minus 0.1, or 90%. That's the power of this test. So we can fill this in. Rejecting the null hypothesis is that type 1 error. We said he has a 15% chance of that. He has a 15% chance of rejecting that he has bag 1 when in fact he actually does. His type 2 error is a 10% chance. Now the nice thing about this chart, it's not quite a two-way table, but the columns do add up to 100. The power we said is 1 minus beta. 1 minus 0.1, he gets 0.9 and 90% power. And of course, his other opportunity to be correct is a 0.85. He can also make a correct decision that way. Remember, false positives are type 1 error. False negatives, type 2 error. So sometimes if you need to find the power, it's just 1 minus the false negative. So let's say he has 2 more bags, bag 3 and bag 4. Bag 3 is 21 black balls, 2 purple, 2 orange. Jot this down on a little sheet of paper. Bag 4 is 3 black, 4 purple, 5 orange. If bag 3 is preferable to bag 4, then we should choose a way that he's going to decide which bag he has. And kind of the way in this one's pretty obvious. It's going to be picking a black ball out of the bag. He's much higher probability to get a black ball in bag 3 than he is in bag 4. It's a very easy way to tell the bags apart. So if he pulls that black ball, he's going to say it's bag 3. Otherwise, he has bag 4. So our null hypothesis, if we think back, same way we did last time, is going to be his null hypothesis is he has bag 3. So his alternative hypothesis is going to be he doesn't have bag 3. Type 1 error here can only occur when he rejects bag 3 when it really is bag 3. And in this case, that would mean he'd have to pull out a purple or orange ball. That's the only way he's going to say he doesn't have bag 3. Let's think about that. That means his chance of a type 1 error, there were 4 of those out of 25 total, or 0.16. His type 2 can only occur if he says it's bag 3 when it's really not. It was actually false that he had bag 4. And in this case, that means he had to pull one of those 3 balls that were black out of bag 4. 3 out of 12 is a 0.25. So his power, the power that we have, is 1 minus 0.25 or 0.75. And it's just so important that if I get asked, or when you're asked, the power of a test is the probability it correctly rejects a false null hypothesis. When the power is high, we can be confident we've looked hard enough at the situation. A high power test helps us. Now, so far we've talked about, and we can summarize our findings in, his probability of rejecting the null when the null is actually true. Type 1 error, we said was 0.16. His type 2 error, we said was 0.25. And that gives us his power is going to be 0.75. And of course, his correct decision opportunity, 0.84. So there's 2 ways he can make correct decisions in this. False positives and false negatives. Now, this website you can go to has some more information on type 1 and type 2 errors. It goes a bit more in detail. You don't have to use it, but it's just another opportunity out there for you. But if you never want to mess up type 1 and type 2, you can think of the story of the boy who cried wolf, because it has both type 1 and type 2 errors. So if we think about wolves, our null hypothesis is there's no wolf. Well, at first, everyone believed there was a wolf. They'd rejected the null hypothesis. But it turns out there was no wolf. That's a type 1 error. They rejected the null when it turns out the null was actually true. There's no wolf, but they thought there was. Second step, they believed there was no wolf. There was no wolf. They failed to reject the null hypothesis, but it turns out there was a wolf. That's a type 2 error. So if you can simply say substitute effect for the word wolf, you're good. Everyone believed there was an effect when it turned out there wasn't. They rejected the null hypothesis when they shouldn't have. Second time around, they believed there was an effect. Turned out there wasn't an effect, but it turned out there was. So false negative, a type 2 error. So our homework for this, power, is it's just this important. This is how we can do it. Now, you can get a type 1. Now, there are 2 ways to increase power. The first one is increase the sample size. If we increase the sample size, which costs us money, we actually reduce all the errors. The chance of all the errors goes down as we increase our sample size. This would be like Houdini pulling the ball, putting it back in, mixing things around, pulling another ball, or doing repeating balls coming out of it, and finding the probability of getting like 4 black balls. It's actually going to reduce the chance of him making either kind of error. So if we increase our sample size, we reduce both errors. The other thing we do is increase significance. If we make alpha larger, beta becomes smaller, which means our power must go up because it's 1 minus beta. So 2 ways to increase power: increase sample size, increase significance. Of course, we had some assignments for this, so go ahead, should be working on these questions already, and I look forward to seeing you soon.